In the name of God, hello, dear students. My name is Masood. I'm a physics teacher. We are in Ferho's website at your service to explain the physics curriculum, grade 10. So far, we finished chapter 1. Right now, we want to solve questions of chapter review. Let's dive in with this lesson. Chapter review and assess page 28 from textbook. Question number 1. Identify at least 2 areas of physics involved in the following. Right? Think about the areas of physics. We had 7 areas of physics: mechanics, thermodynamics, let's say electromagnetism, vibration. Building a louder stereo system in your car. It says, mentions at least 2 areas of physics. Related to what? Related to the, for example, question. Building a louder stereo. It talks about the sound system, right? So vibration and wave phenomena, right? The second one, electromagnetism, right? Because it says a louder stereo in your car. There's a, for example, radio or device. That's why this device has electromagnets. That's why we can say electromagnetism. Let's dive in. Let's go to the another one. B. Bungee jumping. What does bungee jumping have to do with? Right? It has to do with vibration and wave phenomena, because the person, let's say, jumps up and down. So that's why, and it moves. That's why it becomes mechanic and vibration and wave phenomena. Let's move on to another one. C. Judging how hot an electric stove burner is by, let's say, looking at it. So it talks about the temperature. Yeah? How hot? What does it mean? How hot means it has to do with what? It talks about temperature. It has to do with thermodynamics and optics, because it says judging how hot an electric stove burner is by looking at it. Actually, burner has a flame. That's why this flame is visible. That's why I told you anything related to our vision belongs to optics. That's why I mentioned actually the answer mentions optics and thermodynamics. Another one, D. Cooling off on a hot day by diving into a swimming pool. In a hot day, for example, you dive into the swimming pool. That's why it talks about cooling off. I told you anything related to temperature, so it belongs to thermodynamics. The first one, thermodynamics. The second one, mechanics, because you dive. What does it mean? It means you jump down, actually. You move. That's why it belongs to mechanics. Question number 2. Which of the following scenarios, we have some scenarios here, fit the approach for the scientific method? Which one is scientific method? We have some scenarios here. I don't read them for you, actually. I want you to read it. We have some A, B, C, and D. Just I mentioned the answer. The right answer where is, let's say, are A and D. I want you to read it and think about it. Why A and D are correct. Right? Question number 3. You have decided to select a new car by using the scientific method. You want to, let's say, buy a new car by means of what? By using a scientific method. It says how might you proceed. So what's your, let's say, what have, let's say, what should you do actually, right? What should you do? The first one, collect information, and this is the first step of scientific method. Collect information on different cars, actually. Consider between the cars and which one is better, which one is convenient for your, for example, for you and your family. It says different cars. Hypothesize about which car best suits your needs. Actually, that's the first one. So the first one, collecting information and let's say saying building a hypothesis. Right. Two, test your hypothesis with test, let's say, drives. You can drive it, you can try it for better, let's say, the best try actually is to drive a car actually. It's to drive a car. You can take it from the company, you can drive it and travel some distances, and after that decide whether you want to buy it or not. C, interpret the results of your test drives. Interpret it actually. You see, the car goes, for example, it's a stop, doesn't work well. For example, the fourth one, the last one, rethink your needs actually. Rethink your needs and choose the best car to buy. After that, you decide whether you want to buy it or not. Maybe you are not satisfied with some cars because some cars, I don't mention the company actually, it's not nice. Some cars have problem with their stop. Maybe you don't prefer it, prefer these cars. Let's move on to other question. Question number 4. Consider, that's the question. Consider the phrase, the quick brown fox jumped over the lazy dog. It mentions the color of the fox and the, let's say, and the trait of a dog. Dog is lazy and fox is color. Are these information, color and trait of a dog, important for us? It doesn't make sense actually. It says, which details of this situation would a physicist, let's say, who is modeling the path of a fox ignore? So which one should be ignored? It says a brown fox jumps over the lazy dog. See? Jump, we focus on jumping because jump belongs to mechanic, because jumping means motion, but we neglect the color of a fox actually and the trait of a dog. Here, this answer, the fact that the fox is brown and the dog is lazy. Question number 5, let's an appropriate SI base unit with the prefix as needed for measurement, for measuring the following. You have to mention the unit, you have to mention the unit. Here we have some, let's say, branches here. A, the time it takes to play a CD in your stereo. Either you say S or DAS. S means seconds, right? And decasecond. You know what deca is? Deca means 10. Yeah, the value of deca means 10. What do you say about this one? The mass of a sports car. Maybe you mentioned the mass of a car by kilogram or by megagram, right? Kilogram or megagram. Kilo means 1,000, mega means million. See, the length of a soccer field. Actually, the soccer field is measured in meters only. We don't use centimeter. It's not wrong actually if you use centimeter, but usually we use meters for measuring the length of a soccer field. D, the diameter of a large pizza. Diameter of a large pizza, maybe it's pizza is measured in centimeter or let's say decimeter. Deci means 0.1, 10 to the power negative 1 decimeters. Anyway, E, the mass of a single slice of pepperoni. We have a sandwich here. A mass of a single slice of pepperoni, gram or decagram. You can say gram or decagram. It can be because it's one slice. Maybe it reaches grams or decagram. Deca means 10. Yeah, 10 grams. A semester at your school. Semester. How long does it take a semester to, for example, for a school year, for an academic year? Actually, maybe it takes megaseconds, in million seconds. The distance from your home to your school. If you are very close to the school, you can measure the distance between your home and school in meters. But if you are far away from the school, you can say and you can say the distance in kilometers. So either we have meters or kilometers. H, your mass. Our mass actually is measured in kilograms. Kilo is our prefix. I, the length of your physics lab room. The length of the room, actually. Think about the length of a room, and it's measured usually in meters, or we can use, let's say, decameters. I told you deca means 10. And J, your height. Your height is let's say, is measured in 3 units. Either you use centimeter, and it's common actually. Meter and centimeter are very common to measuring the length of the measuring of height of a person. But this, let's say, decameter, it's not wrong actually, but it's not very common. It's not very common. So centimeter, decameter, and millimeter. Excuse me. This is deci. It's not deca, deci. Excuse me. Decimeters. Sorry for this mistake. Number 6, it says, if you square the speed expressed in meters. Another question. We want to square a unit. We have a unit here. What's the unit? Let me try it here for you. We have a unit. It says square. This is our procedure, actually. We want to square what? Square the unit, actually. Square the speed expressed in meters per meter per second, right? In what unit will the answer be expressed? Just write it says it gave it us, actually. It gave us information, meter per second. So I can write the unit of speed, and after that I square. What do I mean by square? Means you square the numerator and denominator separately, and it becomes meter squared over second squared. That's it. This is the answer. Go to question number, let's say 7. If you divide the force measured in newtons, we have a force measured in newtons, and newtons means kilogram meter per second square, right? Right now, I wanna, let's say, read it for you. If you divide the force measured in newtons by what? Force divided by speed, measured or expressed in meter per second. In what units will the answer be expressed? Actually, force over velocity. How much is what's the unit of force actually? Kilogram meter per second square. It gave it to us. We have it within the question. Divided by velocity is expressed in meter per second. Right now, let me do it with you. I want you to be with me. Focus on this one. Pay attention. Kilogram meter multiplied by kilogram meter multiplied by second, like this. Kilogram meter second goes to the numerator, and this one second square multiplied by meter becomes meter second square. Can I cancel meter with meter? So can I, let's say, simplify one s with 1 power of s here? So what thing, let's say, remains? Here we have kilogram over second. This is the answer. Question number 8. The height of a horse is sometimes. Let me bring it here. Question number 8. The height of a horse is sometimes given in units of hands. Yeah, units of hands. Why was this a poor standard for length before it was defined to refer to exactly 20 centimeters? Actually, in back in time, they used the span of a person, actually, or palm of a person for measuring what? For measuring the length of a horse. But after that, they thought that this approach is not very accurate. It's not very precise. Why? Because the size of the span of a person is different from the size of a span for another person. Maybe my hand is, let's say, longer than your hand. That's why the measurement is different from from a hand to hand, from a span to a span. This is the answer. Let's read the answer. Let me read the answer for you. The size of unit varied depending on who was doing the measuring actually. What does it mean? It means it depends on the size of a hand of a person. So by doing so, actually, the reading undergoes overestimation or underestimation by this, let's say, by using the hand. But if you say for example, one hand is equal to 20 centimeter, and you use meter stick actually, or if you use meter stick, is better actually than using the hand. It's old actually, old tool for measuring the length of a horse. Question number 9. Explain the advantages in having the meter officially defined in terms of distance that light travels in a given time interval, rather than the length of a specific, let's say, metal bar. Actually, I told you, it talks about, it compared between two tools, the old tool and the new technique actually. Back in time, they used, let's say, they defined meters as what? They defined meter, they defined meter as what? As in terms of length of a metal bar. But I told you, in SI, System International of Units, they used, let's say, they agreed on what? They agreed on the distance that is traveled by light. This is the length of, this is, let's say, this definition becomes a standard for meters, the distance that is traveled by light. So it says, what's the advantages of replacing the replacing the old definition by the new technique? What's the advantage? It says the size of the unit is standardized and reproducible. The size of the unit, you can, let's say, retake it again. You can do the experiment again and again and again to better, let's say, to getting the best result, right? So that's why scientists agreed on what? Scientists agreed on the distance that is traveled by light between 2 points as a measurement of, as a criteria for meter. Go to the question number 10. Einstein's famous equation indicates that E is equal to mc squared. This is the energy conservation equation. It's Einstein is famous for this equation, where c is the speed of light, measured in speed of light, and m is the object's mass actually. Give this, what's the SI unit of energy? E means energy, m means mass, and c means speed of light. It says, what's the unit of energy? Actually, just substitute the unit of mass and velocity in the equation, right? After that, rearrange it and let's say multiply them together. E is equal to mc squared. This is the original rule for Einstein. E is equal to, mass is measured in kilogram, right? And c is measured in meter per second. Meter per second, the whole bracket square. What does it mean? Means E is measured in kilogram meter square, let's say, over second square.